everyone. In lecture we discussed the fact that sometimes we have a continuous variable and it's more intuitive for us to show our results using an ordinal variable with categories of that continuous data. What we're going to do here is create a categorical variable for number of packs per day instead of number of cigarettes per day. And we're going to use that new variable to calculate the prevalence of coronary heart disease for different levels of smoking at visit 1. So let's get started. We're going to create an ordinal variable called packs1, and we're going to use our cigarettes per day variable to create categories where no cigarettes is going to be of packs1 equal to 0, 1 to 20 cigarettes will be counted as packs1 equals 1, and so forth. So let's go to STATA and open up our Framingham dataset. We're first going to assign everybody a value of missing, which is shown with a dot. And now we're going to start replacing that missing value with a different value of 0, 1, 2, or 3 based on the number of cigarettes per day. And for this final category, keep in mind we always have to say to STATA, make sure that it's less than infinity, because if it's infinity, it'll be counted as missing. So we now have our new variable called packs1. Now we can calculate the prevalence of coronary heart disease by levels of packs1. We're going to go to Statistics, Summary Tables and Tests, Tables, 2A tables with measures of association. Our row variable is going to be our new variable packs1. And our column variable is going to be prevalent coronary heart disease at visit 1. And we're going to ask STATA to show us those relative frequencies. And as you can see, the prevalence of smoking is 4.79% for people who are non-smokers. It goes down to 3.89 for 1 pack per day, 3.77 for 2 packs per day, 3.75 for 3 packs per day. So we see that the prevalence of coronary heart disease is lower for people who smoke more. So we have to ask ourselves, what could explain the higher prevalence of coronary heart disease among non-smokers compared to those who smoke 1 or more cigarettes per day? And keep in mind that a prevalence, as we said before, is based on your incidence and your duration. So it's unlikely, but it is possible, that the people who do not smoke or smoke less have a higher incidence of coronary heart disease. It's also possible that the people who smoke less have less severe coronary heart disease, so they live longer with it, and they have a longer duration of having coronary heart disease, and that's why the prevalence is higher. But both of these seem slightly unlikely. What seems most likely is the fact that we're dealing with cross-sectional data here. We can't distinguish between whether it's the smoking that leads to the coronary heart disease or it's the coronary heart disease that affects your smoking. So while it's technically possible the people who smoke less are more likely to have a higher incidence or a higher duration of coronary heart disease, what seems more likely is that the people who are diagnosed with coronary heart disease are then advised to stop smoking. And just as a reminder, when we had in lecture, we discussed the fact that whenever we're doing an epidemiologic analysis, we need to think about other explanations for why we see an association between two variables. It may be a causal effect of our exposure on our outcome, but there are other reasons that we have to take into account. One possibility is bias. So for instance, we may have a measurement bias here. It could be that people who smoke more are less likely to go see a doctor, and therefore they're less likely to be diagnosed with coronary heart disease. So it's not that they don't have high levels of coronary heart disease, it's just that we're not able to detect it. Another possibility is confounding, and we're going to spend a lot more time in subsequent lectures discussing confounding. But confounding exists when we have some third factor related to the variable of interest as our exposure and our outcome. And this third variable may explain the relationship between an exposure and a given outcome. So for instance, here we may have confounding by coffee intake. One could imagine that people who smoke more are also more likely to drink coffee, and perhaps the coffee is protecting them from the coronary heart disease. And it's not that the smoking is actually lowering the risk of having coronary heart disease. And finally, we discussed the issue of chance. Whenever we're doing an analysis, there is some sampling variability. So it could be that we found a chance finding here. So in conclusion, we saw that we can use STATA to create an ordinal variable based on continuous data, which may help us to come up with a more intuitive result. We discussed the fact that the coronary heart disease prevalence was lower among people with higher levels of smoking. And we thought about the fact that prevalence is a function of incidence and duration, and that in addition to a causal effect of the exposure on our outcome, there are other alternative explanations for observing an association between two factors of interest. See you next time.